In this video, we are talking about rate and catalysts. Now, catalysts speed up the rate of reaction, and one such catalyst is manganese oxide. Okay, and if we show you here, we can show you that manganese oxide is the catalyst for hydrogen peroxide decomposition, and that decomposition takes it to water and oxygen. Okay, and you can see here that here's the activation energy for the normal reaction, and here's the activation energy with a catalyst. So it's lowered that activation energy. Okay, so higher activation energy, and that will mean a lower rate, so it takes more energy to make it happen, and that's without a catalyst. And then lower activation energy, higher rate is with a catalyst, and the catalyst is manganese oxide. Important noting it's a powder. The reason it's a powder is because that increases its surface area, and the surface area increases the rate of reaction as well. So you've got a double thing going on there. Okay, the catalyst increasing the rate of reaction, and the fact that it's powdered as well. And all catalysts tend to be in that powdered form, or in a form that has a high surface area. So we put that to the side, okay, and then start going through it. So reduces the activation energy, really important, through an alternate route. So you need to remember these orange parts here. Alternate route gets you a mark. And we have that intermediate that has a lower energy. Here's the intermediate, and there's the intermediate. So that intermediate has a higher energy than that one, okay, which is with the catalyst. Now, lower activation energy means more successful collisions. More reactions means a faster rate. So you get a faster rate with a catalyst because of this alternative route and reducing the activation energy. Also reduces the time for the reaction, and really important, there are questions about this, lowers the temperature, and so energy usage is less, okay, especially if it's made from fossil fuels. And a good thing to note is if it's done through fossil fuels, you reduce your CO2 emissions as well. So there's your definition, which is here, and then these are the answers that you can be asked about reaction rates. Now, let's finally look at two different types of catalysts, homogeneous and heterogeneous. So homogeneous and heterogeneous just tells you the different types of catalysts that you have. So homogeneous is when the reactants and the catalyst are in the same state. Examples of that is where you've got an enzyme catalyst in a living system, because they're both aqueous. And that can be, for example, when you have liquids that you put in as well. When it comes to transition metals, you can put in liquids into reactions, and you've got an aqueous with an aqueous again. So that's a homogeneous catalyst. Heterogeneous is the most common one in this stage, which is reactants and catalysts are in different states. Hard process is one example of this. The catalyst is iron, it's a solid. The reactants are gaseous. Okay? Now, if I go over on this one as well, so really, really important on this one, hydrogen peroxide, solid catalyst, it's a powder, okay, and an aqueous hydrogen peroxide. So this is an example of a heterogeneous catalyst there. And there are your two types of catalysts and how catalysts increase the rate of reaction through an alternative route with a lower activation energy.